All right, let's get going. We are just about on time. People might trickle in at the end. Welcome to data structures. I understand some other people showed up in here and are not supposed to be in data structures. We are teaching that here. That actually reminds me of an interesting story. I don't know if Bruce, you've heard this story before, but one of the most famous computer scientists in the world is a guy named Donald Knuth. Raise your hand if you've heard of Donald Knuth. Yeah, a few people. He's like super famous. Wrote this giant set of textbooks, is still working on them, called The Art of Computer Programming. And he's also a mathematician. And at one point he, you know how there's abstract math? Well, he taught an abstract math class, and then he came up with another math class called concrete math. And so this was at Stanford. He had this course in the course catalog called Concrete Mathematics. And the first day of class, he started talking about the class, and about like 20 people got up and left. And he realized later that they were all civil engineering students who thought they were going to talk about the mathematics of concrete instead of the mathematics of whatever he was talking about. But it had nothing to do with concrete itself. OK, so my name's Chris Gregg. We are here for data structures. And we've got a PowerPoint up here. I will not kill you with PowerPoint presentations during the year, but it's good to get a couple things up there now on the board, and we will go through some of these things and then have some other board things. There is Bruce over here, which I will introduce in a few minutes. This is a website. Hopefully you can see it here. It says www.cs.tufts.edu/Molay, MOLAY/lab15. To sign up for the labs, you're going to go to that website and fill in some things. And one of the questions on there is going to be, have you taken Comp 11 before? If not, click here. Please do so if you have not taken Comp 11. And that will enable you to suggest times that you'd like to take labs and so forth. We'll get into more details about that a little bit later. All right. I think we've got a quorum here at this point. All right. So here's what we're going to talk about today. I'm going to introduce myself. I'm actually brand new to Tufts University, so probably none of you have seen me before. And I'm going to then introduce some of the other staff for the course. And we're going to talk a little bit about the course goals, like what's data structures all about, what are we trying to learn in here. And then there's still people coming in trying to get into the other class, I think. Too bad for them. And then we're going to talk about data structures in general. Today's more of what I like to call a 50,000-foot view of the class. Okay, everything I talk about in here today, we will kind of be going into much, much more detail about. So if some things at some point you go, I don't know what you're talking about, that's fine. You can certainly ask questions about it now. But I want to give you an overview instead of just instead of digging into the details, just so you kind of get a feel for the bottom line for what we're talking about here. Okay, all right. Who is Chris Gregg? Let me do this. I'm actually going to do the full screen effect here. Show you who I am. As I said, I'm brand new to Tufts, and I suppose in some sense my path here is probably a little different than some other professors. So all my reminders, I got to take out the trash today. Oh my gosh, I forgot to do that. I hope my girlfriend remembered to do that. We're in trouble. Hang on. How do I snooze all? Can I snooze all? No. Hang on. Oh. Snooze to snooze for 2 hours. There we go. All right. All right. Someone remind me to text my girlfriend about the trash. OK. Let's see. Here we go. All right. So Chris Gregg, hopefully you guys can see this, I started out in a little place called Skaneateles, New York, which is the Finger Lakes region of upstate New York. Anybody from New York in here? Where are you from?
Long Island.
Long Island. Oh, no kidding. All right. Jamestown. That's right nearby. OK. Anybody else from around the Syracuse area? How about you guys? Albany?
I'm from New York. I'm not from.
Not from. Are you from New York City? Yeah. So anybody, if you're not from New York City, like there's New York City, and then everything else is upstate, right? Like if you're from New York City, that's kind of the way it goes. Anyway, so that's where I grew up. I went to public high school. I decided to go to college, and one of my choices was actually Tufts University. I loved Tufts. I visited here a long time ago. Sadly, I was a long time ago, but it was one of my top choices. I ended up not going to Tufts, sadly, although there is a picture somewhere. My mom has not sent it to me yet, but there's a picture of me wearing a Tufts sweatshirt, which I got like way back when. So someday I'll prove to you that my loyalties do lie here in that sense. But I ended up going to Johns Hopkins University in Baltimore, Maryland. Quick little story about Tufts versus Johns Hopkins. My family got a puppy when I was in high school, and my dad, who was a little crazy, said, "Hey, let's name it one of the schools you're applying to." So there was, I guess luckily I wasn't applying to like Carnegie Mellon, or the dog would be. But anyway, we were going to name the dog either Tufts or Hopkins. We ended up picking Hopkins, and I ended up at Hopkins. So I studied electrical engineering there, and took a number of, I'm going to zoom out of Baltimore a little bit, took a number of classes at Johns Hopkins in computer science, loved computer science, did take a data structures class. I do not have my notes from them, although I'm not sure it would help me too much. The data structures themselves have stayed roughly the same. Programming languages have not. I learned data structures in the language called Pascal. Anybody ever heard of Pascal? Yeah, it's one of the older, I would say, languages, although, well, it's a relatively old language, but good one nonetheless, but not taught really anymore. So I spent about 4 years at Hopkins, as you do. Well, some of you guys might not if you're going overseas or whatever, but I spent 4 years there, graduated with an electrical engineering degree, computer engineering degree, and then after that, I answered a piece of mail which came to me and said, "Hey, would you like to join the Navy?" And I said, "Sure, I'll join the Navy," as you do, I guess. And so I joined the Navy. The Navy made me into a cryptologist, which is kind of a fun job title anyway. Although most of the stuff I did, I pushed a lot of papers around while the people and managed a lot of people who did a lot of fun stuff. But they sent me to San Diego. And any Californians here? Yeah, where are you from? LA. LA, there you go. San Francisco, okay. Anybody from near San Diego, kind of south of LA? No? All right, well, anyway, it's great. If you haven't been there, amazing place. So I went to San Diego. The Navy then said, "Hey, you're going to go out on a bunch of ships and do these things called Westpacks." And Westpacks stand for Western Pacific. And if you zoom out here, we started in San Diego, went from San Diego past Hawaii, sadly did not stop in Hawaii, went to Singapore up here, which is also an amazing place. I don't imagine there's anybody from Singapore here. Are you really? Hey, I love Singapore. One of my favorite places. And very clean, very safe, all that kind of stuff. It's and just a fun place, great food. Then we went to Malaysia and all that, and then sailed around, ended up, of course, in the Persian Gulf, sailed around there for a while, got to go to Muscat, Oman, and Kuwait, and Bahrain, and all that. And then we sailed back via Australia, down here, which was fantastic. We stopped in a little place called Bunbury, Australia.
From there.
You are not from Bunbury. Are you kidding me? Well, there you go. Well, do you know anybody named Jackie Quinn? All right, well, I met this lovely lady named Jackie Quinn in Bunbury, Australia. But great, loved it there. We were the biggest ship to like ever pull into Bunbury. I mean, a tiny little town, but great place. Normally they pull into Perth and Fremantle, which is kind of north of there. Anyway, so we stopped in Bunbury, loved it, and then sailed around down here through the Bass Strait, and then up into Sydney. Went to Sydney. Met a lovely lady in Sydney as well. Don't tell Jackie. No, Jackie, she's not. And then back to San Diego. And then, of course, did it all over again. 3-year tour, you do it all over again. Missed Hawaii. We did stop in Hawaii on the way back, which was nice. And then, let's see, up to Singapore, this time Thailand. Great trip to Thailand, loved it there. And over to the Persian Gulf, Kuwait, United Arab Emirates, all that. And then, of course, back past Australia. This time we went to Darwin, Australia, way up here. Met a lovely lady there. I promise you I'm not a slut. I promise you. Anyway, and then back to San Diego. And at the end of my time in San Diego, I decided, I wouldn't mind doing another job in the Navy. How about in Australia? And so I found this great exchange program through the Navy back in Australia, in this little place called Gerringong. Have you been to Gerringong? Heard of Gerringong? It's south of Wollongong, south of Sydney. And it is a wonderful little place in New South Wales. right here. If I zoom in a little bit, this is called Wary Beach, which is a great little surf beach. I used to surf right here. Almost got killed numerous times by the surf. I was not a very good surfer, but I loved it anyway. And lived there for 2 years. After the end of that 2 years, I decided, well, the Navy's not going to give me a job as good as any of the ones that I've already had, so I'm done. And I decided I was done with the Navy. And in the process of kind of figuring out what I wanted to do, landed on teaching. And in fact, landed on teaching high school physics. So from Gerringong, I ended up back in this neck of the woods at a little place down the street called Harvard. I got my master's degree in education there and spent a year doing that, doing my student teaching and so forth, and had a lot of fun there. And then instead of going straight into teaching, I decided to spend a summer in Ireland working for the Let's Go tour guide book. I don't know if you've ever gone around and used the Let's Go book, but it's fantastic, and I got to write for it and travel all around the country. Met some nice Irish women. Anyway, and then finally started my teaching career back near here in Brookline, at Brookline High School. Anybody from BHS? Are you really? Yeah. Nice. Who was your physics teacher? Mr. Darian. Andre, good guy. Yep, yep. Did you take it just in 9th grade, or did you take AP as well? Oh, he's not listening. Did you take AP as well, or just 9th grade physics? Oh, you only, okay. All right. They teach freshman physics there. Anyway, great school. So I spent a couple years teaching in Brookline, took 1 year and moved out to Santa Cruz, near San Francisco area, taught out there for a year. I went surfing there a lot as well, also almost got killed a number of times in Santa Cruz. And then back to Brookline, actually, for a couple more years. And then finally I decided, after a few more years of teaching, total of about 7, I think I want to go back and get a PhD. And I kind of went back to my roots, decided I want to get a PhD in computer engineering, started applying to various schools, and landed at University of Virginia in Charlottesville. Any Virginians? Where are you from? Richmond, there you go. Not too far, hour away from Charlottesville. And probably half your class is at UVA, right? Yeah. Yeah. It's either that or Virginia Tech, but we don't like Virginia Tech. This is the computer science building. It's called Rice Hall. It's brand new. It's very nice. It's right next to the football stadium, as you can see. And I spent many long Saturday afternoons listening to football games, writing my dissertation. So I didn't get to actually attend too many football games, but alas. So I spent 4 years there. My degree from there is in computer engineering. It's actually, I studied computer architecture, so low-level computer design at the microchip level through the up to the kind of the software hardware line there, and did a lot of good fun stuff there. And then decided I wanted to teach back in the college level, and so I applied to a number of different teaching jobs, faculty positions, and got a great interview here at Tufts. And came up here, did the interview, went all right, and then a couple weeks later they called me up and said, "Hey, here's a job." Well, as it turns out, I'm still in the Navy Reserves, and the Navy Reserves, if you're in the Navy Reserves, every few years they want their pound of flesh. And so in the meantime, they had called me up and said, "Hey, guess what? We're sending you to Africa." Right? Sending you to Africa for a year. And I thought, whoa, giraffes and lions and cheetahs and all that stuff. And they said, "Well, we're actually sending you to this little tiny place called Djibouti," which, if you've anybody from Djibouti, I don't think anybody's from Djibouti. They might be. This is a dry, desolate, humid, dusty, horrible place, and not. I probably shouldn't say that. It's a very nice place if you like dry, dusty, hot, desert kind of conditions. But I spent a year there. I was, as they say, voluntold. I was going there. There were no questions about it. This is actually where I stayed. I'm kind of surprised Google Earth has these great pictures of the U.S. Navy base up there. But you might be able to see there's like planes in here you're not supposed to look at. But they used to put the bombs on. I probably shouldn't say that. They used to put the bombs on the planes right in here, and it was like 50 feet from where I lived. And I thought, if anybody screws up, I'm done. right? But anyway, the horrible little place I had to live, these little containers, they're like shipping containers, and there's like 2 beds in there, and had a roommate. He was cool. And then spent a year doing that, fighting bad guys, so they tell me, and doing what we call psychological operations, which was, they used to call it that. Now they call it something silly, which is not as nice, or not as cool. And feel free to ask me about that at some point. So anyway, that stalled me for about a year and a half. So this was a year and a half ago that all this happened. And nicely, Tufts said, after a little bit of finagling back and forth, they said, hey, if you want to start working in January of this year, we'd love to have you. So here I am, and back at Tufts. And I am super excited to be here, as you can imagine. It certainly beats the middle of the desert and nowhere. But I'm very much looking forward to teaching you and starting out with data structures. So let me see. Let's go back to this. Let's see if this works. I will put this back up. Any questions about me, where I'm from, or anything like that? No? Feel free to ping me at some point if you want any more information. OK, so that's me. Now, because this class is rather large, you guys are actually the smaller section of 2 sections of Comp 15. We have a ton of other staff involved. First and foremost, Bruce, who you may know from other classes. Bruce is back here waving. Sorry, you guys in the corner can meet him later. Bruce is been a faculty member here for a long time and is a phenomenal programmer and a phenomenal teacher, and is going to be doing mainly working in the labs and putting together assignments and helping me out with that, which is great. And so Bruce is, if you don't know him, you will get to know him through the labs, I'm certain. We also have some TAs. Any of the grad TAs here? Asan is not here, and Ginger is over here, and Sarah came earlier. So anyway, Ginger is a graduate TA, going to be helping out probably in the labs and with grading and so forth. And then we have about 1 million undergraduate TAs. Anybody TAing for Comp 11 in here? Yeah, a couple people are TAing for Comp 11. You are part of the Army for Comp 11, but there's an army of TAs for Comp 15 as well, so you'll meet many of them. And in fact, going forward after this semester, if you like this class and want to continue, participating in some form, we may just pay you to be a TA. So there's a little plug now. OK, so those are the other staff involved with the course. All right, obviously, the course has a number of resources. Hopefully, you've all been to the main web page yet. If you haven't, go ahead at some point. The website's going to have all the assignments on there, all the announcements, all the details about that as they normally do, and the syllabus and so forth. We also have a Piazza web page. I dropped all of your email addresses into the Piazza web page, and hopefully you got an email yesterday saying you're signed up for Piazza. And you may have done that in Comp 11 as well, or other classes. But it's a good kind of forum for answering questions and back and forth and so forth. I did, however, turn off the anonymous posting capability there. So you have to be actually, you have to be willing to say what you want in a non-anonymous way on that. However, if you do have something that you want me to know, I have set up an anonymous feedback web page. Well, it's like a service online called Say At Me. And you can go to that website and then type whatever you want, and it goes directly to me, and you can yell at me and say, you're going too fast, or you're going too slow, or I already know all that stuff, or whatever you want. Or anything meaner if you'd like to. But I probably will only respond to constructive criticism, I suppose, unless it's really funny or something. But anyway, so please use that. Like if you do feel like the class can be directed a little better in one way or another, and you don't want to email me, so that I know who you are, you can feel free to use the anonymous feedback, and I urge you to, if you feel that that's the way you want to contact me. It's fine. The office hours. So we're going to actually post office hours. There will be lots and lots and lots of office hours. They are going to be in the labs in Halligan Hall, where the computer science department is. And we're going to post those at some point in the next few days. And this week, we're actually going to have a number of labs. I'll get to that in a few minutes when we talk about the first assignment and how that's going to work. But there's going to be lots of office hours and lots of people to help out with any programming questions you might have or class questions in general. And then, if you look over here, There's a videotape recorder, and I'm wearing this silly microphone. I'm also going to tape all the classes. So they will be on YouTube at some point after the class. It takes it takes many hours for my computer to crank through the video and actually like format it for YouTube, but they'll be on YouTube. If you do have any problem being on the video, well, sit back that way, too far, or far enough so I don't think anybody actually is on the video except me up here. But anyway, that is going to be for you to use if you miss class for some reason, if you don't want to attend class for some reason, or whatever. It doesn't really bother me. Obviously, I want to see as many of you here as possible, and you can ask questions in kind of a real-time thing. But if you do need to miss class, the video will be there. I only ask that if you miss class and want help at office hours and such, watch the video beforehand so that you don't come in and say, what did we study in class? Now you'll be able to just watch it on the video. I will also post any PowerPoint presentations and so forth on the website as well. So that's that. And then finally, you are welcome to email me. My inbox just completely fills up with emails, as many of yours does as well, I'm sure. So email is probably not the most efficient way to get smaller type questions answered. If you have something big, obviously email me or stop by. What did I say my office was? Hang on. I know it's in my... That's it. That's me. There we go. 228C. So in Halligan Hall. So feel free to stop by if you do want to chat about anything in there. And so those are the big things about resources. Anybody have any questions about class resources? Yes. I have my own like YouTube channel or whatever. I mean, it's not a big deal. It's like Dr. Chris Gregg at YouTube or whatever. But they'll be posted on the lectures page of the website. So and then they'll all be right there. Okay. Anything else? No? Okay. All right. We do have a textbook for the class. Hopefully some of you guys saw my little note on the announcements page already about the textbook. This is a textbook. It's called Data Structures and Other Objects Using C++. It's a decent book. I am not going to assign anything from it. So you can get away with using a previous edition or not getting it at all if you'd like. But it's going to be there for your own reference. So use it as you want. If you have already purchased the latest edition and didn't want to, and want to turn it back in and get, you probably at this point can still get your money back, I imagine. At least I hope so. If you don't want to get it, but we will have it as a reference, and I may point to various places in it at some point about the class, about certain things we're talking about. But you will not be expected to have this ready or obviously bring it to class or anything like that. Okay. All right. Let's see. More expectations. So the programming assignments in here are going to be in C++. Okay, most of you, I understand, took Comp 11, which is a C++-based course as well. So you should be very much up to speed on C++ from that sense. It is not my favorite language in the world. I'm kind of more of a Python programmer and some other languages. I'm not a huge fan of C++ because it's such a robust language that there's lots of ways it can trap you. And hopefully we will mitigate some of those during the class as we'll talk about a little bit later. But you do have to become a relatively proficient C++ programmer. And as far as the language itself goes, yes, you need to learn C++. If you have not taken it before, you do need to get up to speed. We're going to have some labs this week, which are optional, which you can come to try to get up to speed on that. But I do think we'll have a number of fun assignments this is nerdy Chris Gregg saying this. I think we will have assignments that I think are a lot of fun. Hopefully you guys will as well. While I'm thinking about that, one of the things about this class is, first of all, I understand that some of you are going to absolutely love the stuff we do in this class. Well, I hope so. Are going to love the stuff we do in this class because you love programming and it's your thing and it's fantastic. And then the opposite end of the spectrum are those of you who are here because your major tells you have to be here, right? And there's a few of you out there that are like that, and I completely understand that. We will try to make the class such that you get as much out of this class as you need to check that box off, and then, if you don't ever want to program again, great. But I think from the standpoint of dealing with both ends of that spectrum, I think it'll work out all right. Somewhat related, I also, of course, understand that you guys are all college students who have super busy lives, and you're taking 5 different classes, and you're taking soccer, and you're taking, flute lessons and whatever else, right? So I know that you guys are busy, and I don't I certainly understand that this is not your only class and your only thing that you're concentrating on. So some of the assignments will seem like they're pretty long and intense, and they will be, but I also understand that this is not your entire life here. So learn to compartmentalize things, but you do have to put enough work in to get the assignments done. But let it be known that I understand your pain if you have too much to do. Okay. Going another step forward with that, you do need to put in the time to write these programs. We're going to be dealing with some pretty big programs in here, probably bigger programs than you saw in Comp 11 or other programming classes you've been in. And if you get stuck on them, don't wait until the last minute. I mean, you've heard this a million times, but don't wait until the last minute to start an assignment or try to get help on it, because sometimes it's just too much work to do that. But I won't beat that horse anymore. All right. Obviously, follow all the directions. We've got very specific directions on how you actually submit work. A lot of it is going to be graded using an auto-grading system, mainly that Bruce kind of came up with. And what that means is you will submit something using provide, which hopefully Comp 11 people already know all about. You'll submit these things, and then you'll get instant feedback about whether it compiled and whether it meets our requirements. And then very soon after, you'll be able to get responses back about how well your programs did given some other parameters that we have. So you will get a lot of feedback. And I've been told that when I say feedback, or when you get things back, you don't necessarily consider it feedback. When the program says, hey, this didn't work or whatever, that is feedback. You need to take that and then wrap it into whatever you do next, so that you don't do the same thing again. All right. Let's see. Auto grading can't read your mind, so you do need that. We'll also have a setup where we have live grading, which means that you'll finish an assignment, and then you'll have a slot of time where you go to the lab and sit down with a couple of TAs who will go through your code and say, hey, this looks good, and this looks good, and this could have used a little work, and explain, talk you through. And especially if your code's not working, they'll say, what were you thinking here? And then you can explain what you were trying to do. The other idea of in-person grading is so that somebody else looks at your code. As professional programmers, which some of you may end up being, you are never the only one to look at your code. It just is never the case that you're the only one to look at it. So your code actually has to be readable to some extent, right? Other people will review your code and take a look at it in real life, and we want it to work that way. Anybody ever heard of the Obfuscated C programming contest? Anybody know? There's this contest out there that you can sign up for. It's every year or two, and it's people who try to make the most unreadable but runnable code in the world. And next week I'll bring in some examples. I'll flash them up here. But this is like the densest. Like you literally can't. People like shape them into various things. And I mean, in the text, it's really like. I mean, it really is. You cannot read these things. And so there's whole contests on this. But that is the exact opposite of what we want your code to be. So, again, that's that's the expectations there. We are going to be using Unix accounts. Again, Comp 11 people, you're intimately familiar with this, I'm sure. You do need to get a user account if you don't have one. Those of you who haven't taken a programming class here will need to get a computer science ECE account, which is easy to do. And I think the details are on the website. And you're going to end up using this thing called the Unix shell, which is this window that you pull up, and you type in commands, and it runs your programs, compiles your programs, and gives you directory listings and all that. So you'll be able to use that. And you should also use a plain text editor. Okay, you should not be writing your code in Microsoft Word, right? It is just it tries to format it, and it tries to this is like unformatted kind of thing. A plain text editor. You can use one of the old school ones, VI or Vim or Emacs. There's newer ones. One's called Kate, which is very nice. It's a graphical based text editor. Gedit's another one. I use Text Wrangler for my Mac, which is a free one that can actually open files from the server on your local computer, which is pretty nice. So I'll be happy to show you that one at some point. But so you have to get an account if you haven't had one yet. All right, quick note on plagiarism, cheating, and so forth. Please don't share your code with other friends. Like share being email. Like don't pass code around. If you're working with someone and you're helping someone out, and they say, I don't get how to make a pointer to this object or whatever, come here. You can look on the screen and see how they did it, but don't copy and paste their code. Okay? If you do get help from anybody in the class, put down a little comment that says, hey, so-and-so helped me out on this. And then if your code looks somewhat similar to theirs, we'll know that, oh, you guys did talk to each other about it. So that's really all there is to it there. You do have to write your own code for this class. There's a place called Stack Exchange, Stack Overflow online, which is a great, great resource. Don't go onto this resource and put in a question on how to do my programming assignment. Because A, they'll figure it out, and B, we might figure it out, and C, it's just cheating in general. So don't do that. Code that's submitted is owned by Tufts. Why do I say that? Because in case I take it and I send it to some search engine that checks it against all other code to make sure you're not cheating, we can do that. And then finally, it's just really hard to get away with cheating these days on programming assignments, because if something is on Google, I will find it, right? If your code looks funny. And Bruce has got a whole slew of tools which can look at your program and see if it looks like your last program in the sense of style and so forth. And it's pretty easy to tell. So that's that. OK, any questions on the plagiarism cheating? I don't think so. OK, final notes. So the grading, all the grading, we're going to have a midterm and a final and a bunch of assignments and a bunch of labs. And the grading system is all on the syllabus. I won't waste time doing that. And then, again, if you think you're going to struggle with programming, if you're here because you're a cognitive science major and you love, you might love programming, but you're just not, it's not your thing, and you're going to struggle with it, please don't wait until halfway through the semester to come for help. You got to do it now, because programming is the next program will build on the previous one, and so on. So it's I will give you that caveat now. Okay, put in enough at the beginning of the semester to do that. OK, speaking of assignments, the first assignment. So there's a sheet that I handed around. Some of you guys who came in late don't have it. Don't worry about it. You can get it at the end. This describes the first programming assignment. For those of you who did Comp 11, you should have no trouble whatsoever with this assignment. What it is we are giving you a header file, or a C++ interface.h file, for a simple class, and programming class that is called the rectangle. Right? And a rectangle has a length and a width, as all rectangles do. And this program that you are going to create calculates the perimeter, the area, and says whether or not will say whether or not your rectangle is actually a square. Right? Pretty straightforward. This is not hello world, like your first program. This is like your second program, right? But it's a C++ program, so those of you who did Comp 11 should have no problem with it. Those of you who were in Comp 50 or some other class, or have not done C++ programming, you may have a little trouble getting up to speed, but this is an easy enough program that I think we'll be able to teach you how to do it relatively quickly. That said, we're going to have labs this week, which are going to be come whenever you want during the lab times, and get some help on this. If you have not taken Comp 11, I strongly urge you to come to one of these sessions. All right? If you happen to be a really good programmer already and know C++, fine, do the assignment. You'll knock it out and it'll be fine. But if you don't know much C++, please come to this class. OK? Any questions on that? You can read the assignment. We'll go over it again. If you have questions, you can email me about it too. Yes?
Are the lab times posted on the website?
They're not posted yet. Oh, the review ones are posted?
Yeah.
The review labs.
They are.
Oh, they are posted. Oh, there you go. Tomorrow 2 blocks, and then Tuesday 2 blocks. Is that what you said? Yeah. OK. OK. Yeah, we'll make sure there's enough that you can find a time. If you don't fit into one of those times, we'll figure it out how to get it. Yes.
When you go to sign up for your lab time, it has links to the.
Oh, perfect.
Ones.
Oh, to the make ones. OK, good.
It is learn C++.
It has links right from the website. Awesome. OK, great. So anyway, bottom line is, if you think you're going to struggle with this assignment, then please come to the lab sessions, and we'll get you up to speed to the point where you'll be able to pick up next week's assignment relatively easy. Okay, it's just kind of a oh, and by the way, there's no class next Monday because it's Martin Luther King Day. So and then the next class is Wednesday. So we've kind of got this week-long break. So I want you to work on finishing up this assignment. A couple things about the assignment. You are going to create this little main function in one of your files, and it's going to read in a couple of integers from the command line, or from the command line, or somebody types them in, and You're then going to create this rectangle and then compute the area and perimeter and then say whether or not it's a square. Pretty simple. Okay, pretty simple stuff. The other requirements, we're going to have this requirement to make what's called a makefile, which many of you may not have ever heard about, even if you did take Comp 11, because you didn't do makefiles in Comp 11, from what I understand. But you also have to do a README file, which describes kind of what you did. It's not too detailed, but it's going to you have to do that. But the makefile, I will talk a little bit about that, mainly on the next slide. But the makefile is going to simplify your life. Okay, I will leave it at that. It is a little script, basically, that uses a program called make, a Unix program called make, that takes this script, looks through it, and will compile your program based on the set of rules that you assign to it. Okay, so if you're in Comp 11 and you're used to like making a .o file and then taking that and linking it and making a regular executable, the makefile takes care of all that. So it's a little nicer. And you can also use the makefile to do your provide as well, which is the way we submit the assignments into the system. Okay, so you'll see when we get to a makefile what it actually entails. Make is a really big program. It actually compiles all the giant programs that you've used, some form of make or another, and you will only need to know this much make. All right, enough. In fact, the program, we will give you the first makefile, and you'll just be able to tailor it to your own needs for all the other assignments, and it's pretty straightforward. It's going to be very simple. Okay, here is what a makefile actually looks like. Okay, notice it's like 10 lines. Not a big deal. Okay, I'll go through what all these little things mean, and the way you run a makefile is you go into your directory with the files for that assignment, and you type make, and then magic happens, and all of a sudden you have your program built. Okay, here's some of the details. Obviously, you can do comments. Just put a little hash in front of the comment. Okay, and then this line just says, hey, this is the compiler we're going to use, C++ compiler. In Comp 11, I gather you guys used G++ for your compiling. We are going to use a compiler called Clang, or Clang++, which has the great benefit of actually giving you error messages that make sense. Woohoo, right? I think, I mean, I hope so, yeah. It's, some of them you just can't, some error messages, not much you can do. But Clang gives you much better error messages. And it actually tells you exactly where on what line the error message happened, and it points you right to it, and it's great. So we're going to use the Clang compiler for our assignments. And then, of course, we have some flags. The flags are just like the extra command line arguments that give the compiler a little extra, like tell the compiler exactly what to do. The first one there says, make your program small and fast. And you might ask, why don't you always want to do that? But there's various debugging reasons you might not want to set that flag. And then the other flag, the W_all and W_extra flag, says, hey, give me some warnings. Don't stop compiling, but give me the warnings for code that might not look right to the compiler. So it'll warn you about things that may not behave the way you thought they would. So it's good. All right. So that's that. Then you have this next line, which shows you all the dependencies. So see these three files, rectangle_tester.cpp, rectangle.cpp, and rectangle.h. We're going to give you the rectangle.h file. The other two you're going to create for the first assignment. And that line of the makefile says, if any of those files have changed, remake the program. Okay, so if you change one, it knows what time it was created or modified, and then it will recompile it. And the -o says just make it an executable. None of this linking business, which happens kind of behind the scenes. Okay, and then all of your programs get compiled together. There's another line here. Oh, and by the way, the space between commands on various lines, that's actually a tab, not space, 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 space. Make cares about that, and it's been bugging people since the beginning of Make in the 1970s or whatever, that it's an actual tab. But we have to deal with it, and that's the way it goes. So just don't forget. You'll look at your program, you'll go, the make file is fine, but it's not, because there are spaces instead of tabs. So make it a tab. You can also type make clean, make space clean, and this will actually remove your executable. And that happens sometimes if you do this so that you can rebuild the whole program next time. You probably won't need to use that too much for this class. And then finally, Bruce came up with this great idea to make a little line that says provide. So if you type make provide, well, what it does is it runs this command. It says provide for our class, Comp 15, homework 1, and then all the files that you're going to need to put in there, and you're done. You don't have to actually type all those things out for every provide. Okay, so it's kind of nice. And then what happens is the next time, for the next assignment, you take this make file, you put it in your new assignment folder, and then you change this to being homework 2 and all the other files and so forth. Okay, so it's pretty straightforward and not too tricky in the end, and it does save time. Okay, questions on make files? You'll test it out this week. Yes.
I actually have a question about Clang. Is there like a link somewhere to download to compile?
It is on the, well, okay, so if you're using the Unix system, which you're going to be like logged into the Unix system, well, actually, you can't just type clang ++ now. You have to type /user/bin/clang. It's going to be in the actual makefile. I didn't change this one properly, but you'll see it. It's already installed, in other words. If you happen to have a Mac and you do any kind of developing on it, it's probably already installed on that. If you run a Unix, like Linux box of your own, it's probably already installed. They're very easy to install if you want. Yeah. PC, you can download it and install it pretty easily as well. But it's on the Unix system already. Yeah. Yes? It's exactly like G++ in that sense. Yeah, you can do the exact same thing. The problem is, rectangle.h is needed by rectangletester.cpp, and so if you don't put both of them on there, and so and if there's no main function that's in rectangle tester, then you probably will have to type them anyway. But yes, you can do it individually, just like G++. And if you don't know what I'm talking about, come to the first lab. You'll learn that sort of stuff. Okay? If you don't know what G++ means or clang++, come to the first lab. Any other questions on make? All right, so some of you guys have not programmed in C++ before. I'm not talking to all you Comp 11 people. We will get you up to speed with lab times. The write-up you've already got. We're going to give you the interface and the make file, and you should already attend that. If you already have mad C++ skills, then do the assignment, submit it. It'll be great, and no worries, right? But otherwise, please come to those beginning labs. OK. All right, so that's kind of the main stuff about administrative things. Let's talk a little bit about the course goals, like what data structures, huh? Why do we even care about this class? By the way, I consider data structures to be the how to get a job at Google class. Okay, so if you guys, some of you guys, and if you want to do summer internships or whatever, this is the stuff that's going to get you hired. Why? Because Google asks questions which are straight from the types of material that we talk about in this class. Okay, and you will all be great programmers by the end of this. So if you do happen to want to do that at Microsoft or Intel or all these other companies, Amazon or whatever, they will ask you questions that are straight from this class. Okay, but here's what we're going to be talking about. Okay, this is from the syllabus, right? It says students will be able to solve real-world problems by making appropriate data structure choices. I haven't even described what a data structure is yet, but we'll get there. Tailored to the problem. Okay, so you guys are going to have to make choices, and I'll show you an example in a couple minutes about why that's important. Okay, you need to analyze the costs associated with programming choices. We have lots of different costs when we write a program based on the structures that we use in the program. Okay, the choices could be if you pick one structure over the other, the time to run your program may be vastly different than what you'd hoped. The amount of space that your program takes in memory, these days it doesn't really seem to matter that much because you can buy gigabytes of memory. But if you ever do anything on an embedded system or something where there's very small amounts of memory, that becomes more important. And you don't want to have code bloat anyway, so you don't want to use too much memory. And then finally, we're going to write, debug, and test large programs. Now, large is a very, that term is, we're not writing large programs. Like, we're not writing a, internet browser or whatever. But we're writing programs that are probably bigger than ones you've seen before, especially in other classes here. So you're going to have to learn how to deal with, a lot of code in one space. Okay? So when I say data structure choices, you're going to be able to solve real-world problems by making data structure choices. So I don't even care about this. Well, here's the example I'm going to give you. Okay, I'm going to give you an example, and you do not need to understand this example. I mentioned that at the beginning. You do not, all the little various parts about it. But I think you'll get the 50,000-foot view of what this is all about. What we're actually going to do, okay, is we're going to look at the time for. We're going to create a few structures. We're going to create 4 different structures. Okay. Well, I did this on the computer. I'm going to tell you what I've done on this, and then you can go run it if you'd like when you get home. But we're going to have 4 different structures, and they're going to be these containers, these list-like structures. What do I mean by a list? This is what I mean by a list. We're going to create these structures that look like this and have a bunch of little spaces in them. This is all virtual, of course. And you can put an integer in any one of those little boxes. Okay? And this is called like a list-like structure. It's like going to be a list of numbers. So we can put 4 and 2 and 8 and 0 and 1 and 5. Okay? In this structure. Okay? And there's various different types of structures you can create that do basically that exact same thing. Okay? That will look like this in a broad sense. Okay? Here's what we're going to do with those structures. Okay? We're not going to put those numbers in there. We're going to take the structures that we built, and we're going to put 100,000 elements in each one of these. Okay? And 100,000 sounds like a lot. To a computer, it's actually not that much. But we will put 100,000 in there. In fact, what we're going to do is we're going to put the even integers into this list structure. Okay? So we're going to go and we're going to write a little program that's going to say, put 0 in, insert 0 in there, and then 2, and then 4, dot, 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 all the way up to, well, I guess it would be all the way up to 199,998 or whatever, right? We're going to fill this up with these integers. Okay, so we're going to do this in all 4 of those list-like containers. Then we're going to search for 50,000 numbers. Okay, and in fact, we're going to search for the integers from 0 to 50,000 or 49,999, and we're going to go through, but we're not going to search for just the even ones. We're going to search for all of those. So we're going to search for 0. And it's going to look at our little list and it's going to say, is 0 in there? Yes. Is 1 in there? No. Is 2 in there? Boop, yes. Is 3 in there? Right? And it's going to do that for those 50,000 integers. Okay? And then it's going to say, OK, fine. Delete the following integers, 1 through 20,000. So what do you have to do to delete something? Well, you go and you say, let's delete 0. Well, first of all, is 0 in there? You've got to go, oh, yep, it's there. Delete it. Take it out. Right? And then modify the list so that it becomes a regular list. We'll get to that in a second. 1, is it in there? Nope, don't delete it. 2, is it in there? Yep, delete it. OK, you get the idea? What we're going to do with this? That's what each one of these 4 structures is going to do. Okay? The 4 structures that we're going to talk about, okay, you may not have heard of any of these. You may have heard of all of them or some mix of between. Don't worry about it if you don't know what these are. We are going to create an array, which is more or less this structure right here. It's a long bit of memory where each integer is right next to each other, and you can say, I want the 4th one in there. Okay, which one is this one? Yeah, good. Yeah, it depends. Depends what you're talking about. This may be either the first element or the 0th element. In C++, we generally call it the 0th element, so that we can find it. Why do we do that? Well, kind of historical. Some people have claimed that it has to do with memory models and things, but we're going to call this the 0th. This is the 1st, 2nd, 3rd, 4th. So if I wanted the 4th element, I can look right there and grab it and say it happens to be 8. Okay? So that's what an array is. A linked list, which you may have also heard of, is like, here's an integer 0, and somewhere else in memory there's an integer that's 2, right? And this integer has a little, what we call a pointer in part of the code that says there's the other one. Okay, and it doesn't have to be right next to it. Like an array has to be right next to it. And then this one says, well, here's the next one. Okay, so that's what a linked list is. Again, don't worry about the details. Okay, the third one that we're going to make is this thing called a hash table. Okay, a hash table is what you do is you take your integer, like 0, and you apply some mathematical function to it, and you get out an answer that tells you where in some other structure to put that item. Okay? Why do you do that? Well, then you can say, well, OK, I have 0, mathematical formula, it goes right here. And then 2, it goes right here. And it's actually pretty quick to do that and then find it. It's a cool structure. We'll talk about that near the end of the class. And then finally, we're going to make a little binary tree. Okay, a tree structure in computer science looks kind of like this. Okay? Where you might have 0 up here, and then you might have 2, and you might have 4, and 6, and 8, and 10, and 12, and whatever. This is not necessarily the exact structure we'll be using, but it's going to be a structure where you've got this guy has what we call children, which is this is his leftmost child, and this is his rightmost child, and then this guy has children, and so forth. That's another structure. Okay? Yes?
Does it
hold on that question. It's a good question. Do parent nodes need to lie? For certain trees they do. For other trees they don't. That is going to be part of the whichever tree you decide to pick. Very good question altogether, though. Good question. OK, so those of, and again, no need for the details right now. Those 4 types of lists we're going to create. OK? And then we're going to time how long it takes to do all this. 100,000 inserts, 50,000 lookups or searches, and then 20,000 deletes. And here are the results. Okay, this is the overall time to do all that. All right, the array takes about 1.7 seconds to do that. Okay, linked list, kind of the slowpoke in here, takes 8.1 seconds to do that. The hash table takes about 1/100th of a second to do all that. The binary tree that we talked about takes about 2/100ths of a second to do all that. And then I also snuck in this other one, which is called a sorted array. Sorted means that we know the order, and it actually is, in this case, increasing. Both of those happen to be the same. The array that we create is a sorted array, but I'm only telling the compiler or telling the program that it is a sorted array in the last little part. But anyway, if you know that it's a sorted array, you can do this much quicker. You can do it in 0.16 seconds. Okay, so these are the results of doing this program for the different list structures. Okay, and you'll notice that the array versus the hash table is about 140 times difference in speed. The linked list versus the hash table is about 680 times difference. Okay, now you say, all right, well, 8 seconds versus 100th of a second, whatever. It's not like I care about those 8 seconds. Well, if I'd said, instead of said 100,000 integers, I had said 100 million integers, which your computer can handle fairly easily these days, it would instead take about 8,000 seconds, over 2 hours to do that with your linked list, and it would take about 10 seconds to do that with your hash table, right? So there's a pretty significant difference. And in fact, Bruce can attest to the fact that students will sometimes hand in assignments where they pick the wrong structure and it takes days and days to run the assignment. He doesn't let them run that long because he times them, correct, Bruce? And they don't do that. So that's going to be part of this class is going to be figuring that out. Let's dig a little deeper. Let's look at some of the results here for the various things we were doing in these lists. The array. Look at how quick the array inserts. Very, very fast inserts into the array. Okay, you can put a variable in there, or an integer into an array very fast. Why? Well, pretend this is all blank. Put 0 in, it goes right there. Put 2 in, it goes right there. But you don't have to do anything else. It's like, boom, it's right there. Okay? These searches, however, are relatively slow for the array. Why are they so slow? Well, if you don't know that this is sorted, what do you have to do to find if 6 is in this array? You have to check each little box. Is this a 6? No. Is this a 6? No. No. Oh, yes, we got it, right? OK, is this a 1? No. Is this a 1? Is this a 1? Is this all the way to the end? And you got to do that for the ones that aren't there. OK, so it's pretty slow to do that in an array. A linked list, it's even slower to do that because the memory is not contiguous like this, you have to make other assumptions and you have to actually follow these little links, and it just takes a while to do that. And then let's see, deletes for the array. We didn't talk about deletes. Deletes for the array, fairly slow. The delete is relatively slow. Why? If I want to delete 6, what do I first have to do? Find it, right? So you got to spend all the time finding it. Then you have to delete it. The thing about arrays, when you're deleting an array, well, you can't just say, I want to delete 6 and then leave it empty, okay, in an array. That space needs to be filled. Well, it doesn't have to be, but in an array, it generally has to be filled with something else. Well, what do we generally do? One of the ways to do it is to say, OK, well, let's move the 8 there, delete the 8. Let's move the 10 there, delete the 10, and then we're done, right? Well, there's actually a better way. Anybody know a better way for a non-sorted list to if you're going to delete the 8, what you might do? Take the last one. Yeah, you'd grab the last one and you'd put it there, because we don't care if it's sorted, right? Good. But in this case, well, I don't know which one this did, but either way, it's relatively slow, because you do have to do a lot of moving with these things. OK, so linked list, fairly slow, relatively fast inserts, all things considered. Search is very, very slow, and delete's pretty slow too. Again, you have to do this search first, which takes up a lot of time. Hash table. Kind of slow when it comes to inserting, because you have to apply this formula, this mathematical formula, to everything you do, and then find memory, and then put it in the right place. Okay, it does take a little time, but searching is like Why is searching so fast? Because you apply this formula and you know exactly where it is, and if it's there, it's either there or not, and you're done. Okay? And deleting, same thing. Search is very fast. Binary tree, similar to the hash table in that you know where things are going to be located. So we had a question earlier about do the trees, is there some formula to where numbers are? Like, are numbers on this side always bigger than this? Yes, in most trees you've got that information. So it's easy to follow the tree down and say, where's 6? Well, it's going to be this way, then this way. Okay, so we can do that. So it's pretty quick to do that. And then finally, the sorted array. Now, the nice thing about the sorted array is that we have extra information. And one thing I'm going to talk about a lot in this class is the fact that information is like gold for data structures. If you know that the array is already in a sorted order, in other words, you know that it goes from 0 to the end and everything's in order, that's a ton of information you get. Okay? You guys have all played the game where you say, I'm thinking of a number between 1 and 100. What's my number? Right? And what's the first number you're going to guess? 50, right? And then I'm going to say, no, it's lower. And then what are you going to guess? 25, right? Because you're breaking it into these little pieces because you know that my number can't be, you know where in the range my number is. It's the exact same thing with this, right? The exact same thing with an array that's sorted. So that's why sorting is the searching through sorts is very fast. Why? Because you can do this cool, you know enough information to apply that to your search function. You don't have to go through all of them anymore. Okay? So that's the big results for this. I'll get to the bottom line here in a second. We already talked mainly about this, searches and deletes. Bottom line here, look, information is gold. Okay? And if you do have to manipulate your structure such that you have to change things about it, that actually takes time. Okay? It takes a lot of time. And here's the other part about the time. Here's what a computer knows. Right? A computer knows one thing, right? At the bottom-most level. Okay? A computer doesn't know anything about trees. A computer doesn't know anything about linked lists. A computer knows that over here there's a piece of memory, or there's an address for a memory, and then over here there's an address. And the computer knows that there's one big array for all of memory, and that's all you get. Right? If you are going to create your own structure, you've got to fit it into this array structure. That's why arrays are fast at doing some things, because that's like the lowest level of the computer, that the computer knows. But they're bad at other things because it still does take time to look through everything. But you have to kind of shoehorn your data structure into this array form, because that's all the computer really knows. Okay? All right. Let's see what else we have here. I already kind of talked about this. Some structures carry more information because of their design. I talked about that. And then taking time to actually manipulate. Got that. There are a couple other things. Take a look at the searches. We talked about this too. The searches through an array or through a sorted array. What's the big deal? Sorted array gives you information that allows you to do a very, very fast sort. Okay? And we kind of talked about why a hash table is fast at sorting. We'll get into all this later in the class. Still, you're trying to search. You have to do the searches first, and that takes time. And then finally, this is for the people who really want to dig into this. I don't know if you noticed the array versus the sorted array. The array inserts are fast, but relatively fast. But it seems like the sorted array inserts are actually faster. As it turns out, the code that does both of those in my program is exactly the same, like literally exactly the same. That's redundant, but it's the same, right? Why? Because the first array we did is sorted, right? It's 0, 2, 4, 6, 8, etc. It is sorted. Why then is the array faster than the slower than the sorted array to insert? Turns out that I didn't think about this when I wrote this program. There's this, and I kind of lied to you earlier. The computer knows about this long piece of memory. The computer also has other little boxes of memory, some smaller than others, called cache. Okay? And cache in your computer, if you've ever bought a computer, you buy this. You buy the DRAM, which is the main memory for your computer, and you buy gigabytes and gigabytes of this DRAM. The chip designers, Intel and AMD, put on the chip itself other very, very fast, in fact, much faster memory on the chip itself called either SRAM or some other types of RAM that are very, very fast, but limited in the amount. Okay? The question is, why don't you make your memory be this fast type of memory? Anybody know? It's expensive, exactly. You can't go and buy this amount of memory for this. And it's also, this is actually built into the chip itself, which makes it faster. Electrical signals do take time to move from place to place, so there's that as well. But anyway, the chip designers build in some memory. And what the cache does is the cache says, oh, I'm using these 3 values a lot, or I'm using the program that I'm using these array things a lot. Well, I'm going to put that in the nice fast memory, or I'm going to put it in the super fast memory, and then I'm going to use it there faster. So as it turns out, because I ran the array first and then the sorted array, it actually is faster because it's in the cache. And then I went home there was a class earlier today where I mentioned this, and I said I'd actually go test it. Well, I went back to my office and I tested. I switched it. I first did the sorted array, then I did the array. Exactly the opposite. The sorted array took longer and the array took less time. So I believe that's probably the right reason for the cache. But so you have to, those things are like when we really dig into the weeds about these things. If you take Comp 40, you will get into this sort of stuff coming up after this class. OK, questions on the example? What's the bottom line on this example thing? Bottom line is we have to think about these kinds of ideas as far as time or as far as space in order to make our programs run efficiently, which is really what you want to do. Okay, you want to run things efficiently. Why? Because you've only got so much time. Some of the programs for other classes probably would have taken until the heat death of the universe to finish, right? Like that is too much time, right? When you could also write it in a very, you could write it using a different data structure and make it super fast. Okay. Somebody in the earlier class asked, why are you going to grade on whether or not our programs are fast? Well, yes, to an extent, we want you to use the proper data structure for the assignment. And we're going to give you assignments where you get to pick which data structures you actually use, right? So you're going to have to make that. You're going to have to make those decisions. And you'll hopefully, during your own program testing, you'll figure out, hey, this is taking a long, long time, right? And you'll figure it out. Or you'll come to lab and you'll, maybe get straightened out in that sense. But some of you will put in programs that Bruce's scripts will die on because they're taking too long, right? But you'll learn about that. Okay. Any other questions on that? Okay, that was kind of the big overview of the idea. Okay. All right, a couple other things that we're going to talk about. So before I let you out of here, in class here we're going to talk about abstraction and abstract data types. So if you take a look at the list structures that we used, all of those different list structures that we used, those list-like containers, had a couple of different properties. You could insert things into them, you could search through them, and you could delete from them, right? That in itself is a very abstract concept. How you go about doing that, like the details of that, are the part that the programmer who puts those together will end up coming up with. Okay, and so abstraction is a really big idea that you can take a 50,000-foot view of something, figure out why, what the overall picture is, and then use that to make other decisions. Okay, if you go to Wikipedia, it'll say the abstraction is the process of separating ideas from specific instances. This class is doing both of those, right? On the one, we're like Law and Order, right? We're doing like the police work and then the lawyer work, right? The police work is like doing separating these big ideas, okay? And coming up with the ideas for how things are designed and why they're designed that way and what that's. And then the other part is actually designing the programs and implementing them. That's going from abstract to the concrete in this sense. Okay? All right. And let's see. Did I miss this one? I might have already done this one. Hang on. There we go. Abstract data. The other one that we're going to talk about is this idea of an abstract data type. And that's we kind of just mentioned it a little bit. But an abstract data type is this model for a data structure that gives that high-level overview and is able to hide some of that information about the details, in fact, all of it, the details, from somebody who's using your data structure. Okay, you're going to be doing both sides of it, so you might not see that as much on your end. But for example, is this array. You can either get something from an array or you can set something into an array. That's all you can do, right? You can either look at it or you can set a value. And we don't care how that's implemented. Right at the bottom, I don't care how the computer actually does this, right? I mean, you could farm this out to a bunch of monkeys who each have like a bucket, and like you're monkey number 7, and here's your your thing. It doesn't really matter, right? Who cares how it's actually implemented? You care about that when you talk about speed and time and efficiency, but we don't care about that from the bigger perspective. Okay, those are what's left up to the designer. Okay, so finally, why do we care about this in Comp 15? Well, we're concerned about the design. That's kind of the point. And again, that's why Google and Amazon and all ask questions like this during interviews. Why? Because they care that you understand the differences between designs and you can articulate why one thing's important over the other for your type of program. And finally, the other one is that the abstract data types actually hide those details. So if you ever go use an array, well, you don't know what's going on underneath it until you take Comp 40 when you learn all about that. Right? You're not concerned with it, and it makes your job as a programmer easier because someone else has figured out all that lower level details. Okay? And so we're the ones who want to have the high level understanding. Okay, so next week we're going to, remember we don't have class on Monday. Wednesday we're going to start digging into some of these structures in particular. So I tell you what, why don't I open it up for any other questions about the class, and then we'll go from there. Yes?
When do regular labs start?
Regular labs are going to start next week. Yeah, I'll. Yeah. 2 weeks. Right, because there's no class Monday, so not next week. 2 weeks from now they'll start. So still get your requests in early enough so that we can place you properly. Okay, I guarantee you we'll find you a place that will fit into your schedule. It may be later in the evening or whatever, but we will fit you into a lab. Do that, and then the actual labs will start then next week. Okay. Other questions? Yes.
Yeah, if we can't make the 3 o'clock time, or we make the 10:30 time for whatever reason, is there a procedure we have to go through to?
No, just show up. Okay. I mean, the other one's more crowded, although it's pretty crowded in here, but it should be fine. If it turns out that everybody wants to show up, then I'll have to make some call, but it shouldn't be a big deal. Yes?
Is it 1 lab a week? Or
One lab a week. Yep. Other questions? I think somebody in the back had a... No. Okay. All right. Well, look, I look forward to the year. I think it'll be great. And I'll see you guys, if not in lab, next Wednesday.